Hi everyone. I'm here at Parkland College's machine shop in Champaign, Illinois, and I'm going to do a demo of a basic machining project. In choosing a project for my basic machining class, I need to make sure that it's something that is doable within the 15-week time period of the class, especially since we only meet once a week. I also want to try to make it useful for students who don't particularly want to go into machining, because there's a lot of students who take this class because it's required for their major. So the thought popped into my head of making a tap wrench. It's simple enough that they can make it within the 15-week time period, and it's useful to people who want to be diesel mechanics or welders or just hobbyists. I was originally going to copy the Starrett tap wrench, and I really liked that design, but I started thinking this might be too much project for the semester. Then another much better known YouTuber named This Old Tony came out with a video on just that, a tap wrench that was really simple. So naturally I decided to steal his design instead. Thanks, Tony. I'm going to start this video just a little bit differently and just say what I'm doing in captions. I think it'll flow a little bit better, and then when it gets into the detailed work I'll start talking again. I have both of my pieces set up in the vise right now, and I'm going to find the edges on both of them. What I need to find is the center of each part, so I'm going to find the edge over here and zero my digital readout, and then find the edge over here and split the difference between those two measurements. I've got a second camera trained on the digital readout, so I'll try to sync these up, and that way you can see all the action. Once I've found the edge on this and I've got the center location, I'm actually going to move over and do the same here, but I'm going to switch from absolute mode on the digital readout to incremental mode on the digital readout. That allows me to have two completely separate zeros that are independent of each other. That means I can machine both of these parts entirely in this one setup. First edge, I'm zeroing my x-axis. There's my second edge. My digital readout is showing 1.9348. Now I could take out a calculator and I could divide that in half and then move to that measurement, or I could go ahead and use this button, which is the half function on the digital readout, and most digital readouts have this. I'll hit the half button, I select my x-axis, and it cuts the measurement in half for me. Now all I need to do is move to 0. When you use this technique, you don't have to worry about compensating for half the diameter of the tip of your edge finder. You've found it over here and you've zeroed, and when you move over here, you're offset the opposite way. So no matter what, if you cut that measurement in half, you end up right in the middle of your part. Now I'm going to do the same thing with the y-axis. Hit my half function again. This time I'm going to choose the y-axis. And again, I just move into 0. Now we're right in the middle of the part on the y-axis. Now, the center of this part is also the center of this part, so I don't have to touch the y-axis ever again. Every digital readout I've ever seen has had a button that says absolute and incremental. So when I hit this button, it allows me to have a completely separate set of measurements. So my y-axis measurement is going to be the same. I'll go ahead and 0 that. Now I can come over to my second part and I can 0 my x, and I'll be able to keep track of the centers of both pieces at the same time. I'm going to hit my half button again and choose that. And now when I come into 0 here, I'll be in the middle of the part. Now that I know where the zeros are for each of my pieces, I can go ahead and drill all of my holes. And since I've got my digital readout, I can move between each one without having to change tools. That's going to save me a lot of time. So I've got a center drill set up here. I'm going to use that as a spot drill. And right now I'm at my first hole location, which is a ½ inch from the center of this piece. I should note that right now these are right off of the saw. I have not cut these to length because the sides end up being radiused. So if I base everything off of the middle of the part instead of the ends, then the ends don't matter at all. I can cut them later. I've moved to my second location now, which is just a ½ inch on the other side of 0, and I'll go ahead and spot now. Now I can move back over to my second piece, and all I need to do is hit my absolute incremental button again, and it has saved the 0 for the middle of this part. All I have to do now is move over to ½ inch on either side of center and spot there. I should point out that the hole locations are the only critical feature of this part. If you don't get the spacing consistent between this piece and this piece, the part is not going to fit, and it's not going to perform the way it should. There's all my spotting done. I'm going to switch to my tap drill, and I'm going to drill this hole and this hole, and then I can go ahead and countersink it and tap it. At this point, there's just going to be a lot of repetitious cranking and drilling. So I'm going to stop talking for the most part, and I'll put some captions up to describe what each operation is doing. At this point, I'm ready to take these out. I'm going to need to do some deburring to these holes as well as the underside of each hole. I'm going to put both pieces onto a fixture to cut our V-notch in it. And I'm doing that because I want to make sure that the V is lined up between each of the two pieces. If I were to try to put the V in individually, then I might be off one way or another from center, and it would be very difficult to get it consistent, both in location side to side and in depth. In addition to that, we have a V on both sides, a deeper one on one side and a shallower one for smaller taps on the other. Because of that, I'm going to cut the V with the standard square end mill, but with the head tilted at 45 degrees. I'm about to make my fixture for holding these, and I want to orient them like this. So I have a tapped hole and a reamed hole on this back piece, and then the reamed hole and the tapped hole opposite on this front one. The reason I'm doing that is because in use they're going to be folded up like this. So if I hold them this way on the fixture, then my V is going to go right down the middle here, just like this. And that way they're going to be guaranteed to line up. To hold these on the fixture, I'm going to use two 5/16 pins in the tapped holes, because 5/16 is the tap drill size for these holes. Then I'm also going to use two shoulder bolts that have a 3/8 diameter shoulder that is 5/8 of an inch long, the size of our stock. That means I'm going to make two tapped holes, caddy corner from each other, and two reamed holes. Just like that. I've grabbed a piece of scrap out of the scrap bin, and that's the great thing about teaching at a college. There's no shortage of scrap from all those class projects that have gone awry. The locations of the holes within this surface really don't matter at all. There's no reason to put them in any particular spot because you're going to find the location on the parts themselves, not on the fixture. What does matter is their spacing from side to side, because that is the critical dimension on these guys. Their spacing this way can actually be pretty loose as well. Theoretically, the spacing between these two holes this way is 5/8 of an inch, which is the thickness of the stock. But a lot of times stock might be oversized or undersized from the mill, and that means that you can't really rely on that being exact. And if you were to make it too tight, they might not fit on the fixture. Let's jump right in and start making some holes. I'm just going to set this one as my 0 arbitrarily on both axes. and then I'll just space my holes accordingly. So at this point, all my holes are drilled, and what I'm going to do is take it out. I'm going to move over to the arbor press and press in these pins. I'll do some deburring first as well, because I've got burrs on here as well as on the underside. It doesn't matter in the slightest right now if I take this out and then put it back in, because I'm going to be angling the head to cut the V, and that would make me lose my location anyway. I'm over here at our arbor press, and I'm going to press our pins into these two reamed holes. I reamed these 1/1000th under 5/16 so that this will press right in. There's a little bit of a pitfall when it comes to pressing pins into reamed holes. It's possible when you start this pin, if you were to just put it right there and press it, you could actually be at a bit of an angle, and you can bend your pin, or you can actually press it in at an angle and just deform the metal on the hole. That would affect your fit, of course. What I'm going to do is use my part as a guide. So here, this is guaranteeing that the pin is going to go in straight, and I'm going to start it right about there, and it's also going to act as a stop. So basically I'll stop as soon as the ram of the arbor press hits the top of my part. Just like that. Dowel pins have a rounded end and a chamfered end. I usually press in the chamfered end. I don't really know that it matters, it's just the way that I've always done it. It seems to make sense to me. Now our fixture's ready to put back into the mill, and we'll angle the head and cut our V's. To cut the V's, I'm going to angle the head 45 degrees. I'm doing this because it's going to allow us to only move one axis when we're adjusting the depth of our V's. If we angled our fixture so our part was angled, and we went to change our depth, we would have to move both the Z and the X axis in order to get our proper depth. Doing it this way is going to make this job a whole lot easier. And in general, anytime you've got the opportunity to make your job easier, you should take it. If it saves you time, it makes you more money, or your employers anyway. So this should be really interesting to the shop owners out there. Never underestimate the ingenuity of a lazy person. Now to angle the head, you could easily just go off of these degree markings, and that would probably be fine. You're machining both of the pieces at the same time, so you're going to get a square regardless of what angle this is set at. I'm going to be setting it with one of these digital protractors. Now this one came from Harbor Freight, and it's relatively inexpensive. I think it was around $30 or $35, and I used one of the 20% off coupons, so I got a really good deal on it. It's also got magnets on it, so it's going to stick to the side of the quill, which is what I really like about this one. I've got it stuck to the side of the quill. Let me go ahead and adjust this until it says 45, and then we'll start cutting. I'm going to go ahead and torque the bolts back down. Go ahead and take this off, and now we're ready to start making cuts. We need to get this V somewhere near the center of our pieces, so what I did was color in the middle of my piece with a black permanent marker. Of course, you could use some kind of layout fluid there as well. And I'm going to measure my piece and then scribe a line down the middle of it from both sides. So measuring my piece, it's coming in at 1.734 inches. And if I do my math correctly, half of that is 0.8675309. I've set my calipers for 867 thousandths, and I'm just going to scribe a line right down the middle of it from each end. That way it splits any difference that there might be. Now this is just a crude layout mark that's going to allow us to touch off somewhere near that scribe line with the corner of our end mill, and then we'll cut our V. I've already scribed my other one, but its measurement did not correspond to the title of a classic rock song, so I didn't put it on camera. I'm going to slide these over my pins. This is the tapped hole going over the pins, and now I'm going to put in my shoulder bolts. The bolts are holding them nice and sturdy. When I did my spacing front to back, by the way, I gave myself an extra 0.010 of an inch to make sure that there's just a little bit of a gap in between the two pieces and they're not going to touch and bind up. Now I'm going to just raise the knee up and touch off at the scribe line. Now there is a pretty darn good chance that I'm going to machine into these bolt heads. And it doesn't really matter. They're just bolt heads. Go for it. As long as it doesn't destroy your cutter, you should be fine. Right now, I've just got it eyeballed where the corner of that end mill is over my scribe mark, and it's pretty close. I'm going to go ahead and turn on the machine now, and we'll not only touch off on our Z depth and zero that, but we'll go ahead and refine our location a little bit. I've touched off and I've zeroed my knee, and it looks like I'm pretty close to the scribe line, so I'm going to go ahead and make our pass there. It looks like I am definitely going to machine into these bolt heads, so I'm going to make a couple of passes just to make sure that it's not too hard on the end mill. It really doesn't matter which V you do first, so I'm going to do the shallower of the two, since that way I'll just be moving in one direction on the knee. The bolt heads don't seem to be that hard, so that's a good thing. I'm just taking 20 thousandths at a time though, just to be safe. This will be my last pass on this side, up to my final depth of 88 thousandths. Now in reality, the depth of each slot really doesn't matter that much. Your taps are still going to fit in it, and it's designed so that there will be a little bit of a gap between the two pieces when even the smallest tap is in this slot. So what I'm saying is there's really no need to measure this. If this was a critical dimension, you could do your trig, or do what I do and draw it up in AutoCAD, and figure out, as far as your extremes for your tolerances, what size pin would be zeroed at the surface. And then you can check with that size pin and a depth micrometer. We most certainly do not have to do that here. So I'm going to blow all the chips off, take out my screws, and then flip it over, and we'll do the deeper slot. Before I take my first cut on the other side, I am most certainly going to drop my knee back down, because I don't want that first cut to be 88 thousandths deep. That might be very destructive to this end mill. I'm going to keep these in the same orientation as far as which part is where. I don't really think that matters all that much, but better safe than sorry. Okay, we're flipped over and we're ready to make our first cut. And again, I have dropped my knee back down so that right now it's at 0, which would be the edge of the cutter on the surface of the part. So I'll actually crank it back up to 20, which was my first cut the first time. With this setup, you want to be extra special careful with your end mill, because if you chip this and you have to replace the cutter, you're going to have to find your location again. So try not to do that. For deburring jobs like this, it's a perfect application for what's called a safe edge file. And this is just a regular file where I've ground the teeth off of one side on a belt sander. The wonderful thing about these is it will no longer dig in on this edge. So when you're deburring a V, such as this, you can safely get just this edge and then flip it over and get just this edge over here, and you're not going to have problems where you dig into the opposite face. This is a really handy modification to make to any type of file. I have a bunch of these made up in different lengths and bastard cut, smooth cut, second cut, as well as square files and triangular files. To make the radii on the end of our pieces, I'm going to use an old trick where we take a dowel pin, we put it through our hole, and we're going to be resting the dowel pin on top of the vice jaws. Now then all we'll need to do is make cuts back and forth across on the y-axis, and eventually we're going to end up with our radii. Now in order to do this, we need to know a couple of things. First of all, the diameter of our pins. In this case, we have two different diameters. We have 3/8 diameter for one side, and then for the tapped holes, we have a 5/16 pin. We're going to need to find the surface of the vice jaw because that's what the pin is resting on. To do that, we're going to use another old trick, which is using a piece of paper and sliding it back and forth on the vice jaw onto the cutter until it grabs. Then we know that we are the thickness of this paper above the vice jaw. This is regular copy paper, so it's 4/1000 of an inch thick. Once we know where the vice jaw is, then we'll need to move up the radius of the pin and then up again the radius of our part. Let's find the vice jaw first. I've got my piece of paper and I'm maybe 1/16 of an inch above the vice jaw right now with the cutter. I'm slowly raising the knee as I move the paper back and forth, and when it grabs, I know that I'm the thickness of the paper above the vice jaw, which is right there. Like I said before, the paper is 4/1000 of an inch thick, so I've set the dial on my knee handle 4/1000 before 0. That way, if I were to crank all the way up to 0, I would be at the vice jaw. We're actually going to be cranking the table down. We need to compensate for the radius of the pin. On the clearance hole side, this is a 3/8 pin, and that means the radius is 0.1875. And then we have the radius of our part. The stock is 5/8 of an inch square, which means our radius is 0.3125. That means that we just add 0.3125 and 0.1875 to get the height above our vice jaw. We'll use the same procedure on the tapped hole, except this is a 5/16 pin, so the radius of that is 0.15625 plus our 0.3125 for the radius of our part. Now that we're set up, it's just a matter of clamping the part in the vise, and we're going to take a series of cuts while we rotate the part around that pin. The pin will always be sitting on top of the vice jaws, so our radius is going to remain constant all the way around. I do recommend stopping the mill in between each of these cuts. Your fingers would otherwise be very close to the cutter. You can see we end up with a radius of sorts, but we have all these little facets from the different cuts. Now, of course, we could just make more cuts and refine it that way, or we can do it with a file, or take it over to the belt sander and do it that way. Honestly, this radius doesn't matter very much. It's strictly decorative. I'm going to finish it up on the belt sander, but this has removed a lot of the material that I'd otherwise be sanding off, and it's going to make the radii just a bit more consistent. The process is going to be the exact same when we do the radius on the other end. We'll just have to adjust our height. I've got my height readjusted for the 3/8 diameter pin, and when I'm making these cuts, I'm trying to keep my cutter centered over the pin. That way I don't have to move around very much side to side. That should be plenty close enough to go ahead and refine this with either a file or the belt sander. Now, is this the only way to make these radii? Of course not. You could easily take a radius gauge or a piece of 5/8 stock and scribe a line around it and then just sand to that line. Now, that would be a bit time consuming and you'd have to keep dunking the part in water to keep it cool enough to hold, but it's certainly a valid way of doing it. You could also, if you really wanted to, set it up on a rotary table and cut it that way. Now, if you have access to a CNC machine, of course, that would make the job incredibly simple. For now, though, let's move over to the belt sander. You could do this at either a belt sander like this or a disc sander, but whatever you use, just make sure to square up the table to the belt first. Otherwise, you're going to end up with more grind on one side than the other, and it's going to look uneven. There we are, some nice refined radii all the way around, and they look reasonably decent. The radii are really not necessary in the slightest. It's strictly aesthetic. So if you're doing this at home, you can feel free to just mill the ends square and maybe put some nice bevels on it. Do whatever you want. For my students there at Parkland, though, I want you to go ahead and make it like the print. The really cool thing about this project is you can scale it up or down however big you want. You can scale it down if you want for the smaller taps, just use smaller square stock and a shallower V, or you can use larger square stock and make it really huge, big enough to hold large pipe taps. I want to actually go ahead and challenge my regular viewers out there. If you make one that's big enough for a 2-inch pipe tap, I want you to send me pictures of it. I think it would be really awesome. If you have any questions or comments, please feel free to leave them down in the comment section below. And hopefully you got something good out of this video. Maybe you saw something that you've never seen before. If you haven't already, please consider hitting the like and subscribe button down below. And thank you very much for watching. I'll see you next time.